Action. Okay, so we have the first derivative test and finding extrema. I'm Rose, that's Heather, Emily, and Anna. And so the first derivative test is it's pretty cool. So when f prime is positive, f of x increases, and when f prime is negative, f of x decreases.
Okay, well,
So
Go ahead.
So determining extreme values through the first derivative test. So you're going to take a critical point, we used 0, and plug in numbers on both sides. And if it's a maximum, it'll be positive, negative, and if it's a minimum, it'll be negative, positive.
We have a few special guests here for moral support. So this is the review of critical values. There's 3 types: absolute maxes and mins, local maxes and mins, and endpoints, which is only unopposed domains. To find critical values, you take the derivative of f of x and set it equal to 0, solve for x, or find where x does not exist. Those are your critical points.
Alright, so this is using the first derivative test. So our equation right here is x cubed minus 12x minus 5. And the first step you're going to want to do is you want to take the derivative. And right here, it's 3x squared minus 12. And from that, you're going to want to find the critical points of that equation. And if you just solve it, it's plus or minus 2. And then we're going to set up the little chart. And what I did was I chose a value less than negative 2, value in between negative 2 and positive 2, and a value greater than positive 2. And when you plug those values into the original equation, you either get a positive or a negative value. And from that, you can tell if it's increasing or decreasing. And if you draw the little line graph, you can easily see that there's local mins and maxes. So this local max means that at negative 2 has the local max, and at positive 2 has the local min.
Action.
Alright, so we got another example of the first derivative test. So our function is f of x equals x squared minus 3 times e to the x. So for this function, you will use the product rule, which is u times v prime plus v times u prime. So if you go ahead and plug that in, you get x squared minus 3 times the derivative of e to the x plus the derivative of x squared minus 3 times e to the x. So if you solve that out, you eventually get x squared plus 2x minus 3 times e to the x. And so we're going to try and find the critical points of those. So you set that equal to 0, solve it out, you get x equals negative 3 and x equals 1. So over here, we got our critical points, and so you plug in the little chart, and you can find that there's a local maximum at x equals negative 3 and a local minimum at x equals 1.